Let's talk about another unit that is used to measure angles. So this unit is called the radian. So radian is considered as a universal unit. The reason is it does not depend on like just numbers that we created. So it's coming from the properties of a circle. So let's say what we mean by a radian 1. So let's look at a circle. The radius of this one is r. So let's say this is r, radius r. Now what we're gonna do, we're gonna consider an arc on the circle which has the exact same length as the radius. So we're gonna pick an arc which is exactly the same length as the radius. So something like that. This equal to the length of the radius. And then we can consider this angle. What is the subtended angle from that arc? This angle is what we call the radian 1. So this angle is defined as radian 1. So radian 1. So there's a 1 radian. So we can write like that. So 1 radian. I say we write RAD for radian equals the angle subtended by an arc of length r. Arc of length r. R is the radius of the circle. So this works for any circle. So it doesn't matter. So you draw a circle and then draw an arc of length r that is equal to the length of the radius. The angle subtended in the center is called 1 radian. So that's how we define. And then you can see like roughly if you look at this one, it's like very close to 60 degrees. So later we're gonna find that exact number. So for the moment, so you can see 1 radian is, I'm going to give you this value. So this is roughly 57 degrees. So it's approximately 57 degrees, 57.3 degrees. So you can see this is less than 60 degrees. So close to 60. Okay, that's how we define radian 1. Now, so this is from geometry. It can be proved that it can be proved that so if you look at any circle and what we're going to do, this is the diameter. So diameter that's passed through the center of the circle, diameter. So let's say, so this is the diameter, that's the length of the diameter. And then so this is C, we're going to call this the length of the circumference. So this is C. So the length of the circumference. And if you take the ratio, so this is true for any circle. If you look at the ratio between the two, so what ratio? So the circumference to the diameter. So you can prove that from geometry, this ratio is a constant. You can see that. So if you draw any circle, and if you measure the circumference and if you divide by the diameter, if you look at the ratio, and you can see that, you can prove that this is a constant. This ratio between the circle and the diameter can be a constant. So what is that constant? This constant is a very interesting number. That constant we call pi. So we're going to give the letter pi for that constant. So this is roughly, that's where the pi coming from. So that constant we call pi. So it is roughly 3.1415 like that. That's an irrational number. And then from that we're going to get the formula. So C equal pi d, that we multiply diameter, but diameter is 2 times the radius. There are 2 radii here. So the 2 times the radius. So we're going to get the formula 2 pi r for the circumference of a circle. So that's where it's coming from. So see, the circumference or perimeter of a circle is 2 pi r, because it's simply coming from the geometric result. The ratio between the circumference and the diameter is a constant. That constant we call pi, and then we can get this formula. So it's a very interesting idea. Good. So now let's see how you can measure other angles. So let's talk about the radian measure now. So the radian measure. Radian measure. So let's look at a general arc. So let's say we have a sector, so like that, and that's the arc. So let's say the arc length is S. So that's the arc length. That's the arc length, and that is the angle here, and that's the radius. So this is the radius. Now the question is how you can measure this angle in radian. So what we can do, we're gonna look at this ratio between the arc length and the radius. This ratio is what we call the angle in radian. So that's how we define, this is a definition, that's how we define the angle theta. We take the ratio between the arc length and the radius. So only condition that has to be, these two have to be the same unit. So this has to be the same unit. So we put the same, so centimeter, inches, whatever, same unit. And then that the ratio is what we call the radian theta. The ratio is called the radian theta. It's just a number. That number is called the radian theta. So the radian doesn't have a unit because you can see it's going to cancel out. So its radian is just a number. So now from this we can have this formula. If you cross multiply, you can see that S equal R theta. So we have this very interesting formula from radian. The arc length is radius times the angle, but theta has to be in radian. So we call this formula as the arc length formula. So arc length formula. This will be useful later. And then so the conversion, what we need to know is the theta has to be in radian. And as before, these two have the same unit. This and that have the same unit. And theta has to be in radians. So if it is given in degrees, you have to convert that and then use that in the formula. Okay, so let's look at a like a circle. So for a circle, so this is a circle. So we can write this special situation. So we have a circle. This complete angle is in degrees, 360 degrees. Now we can use this formula here because we know the radius. So let's say this is radius r. Now we can use this formula. So we know that S equal r theta. So let's plug in. For radius r, we know the circumference. We just found that it is equals to 2 pi r. On the other side, this is r times theta. So you can see that r get cancelled. So you get the angle theta is exactly equal to 2 pi. But we know that in degrees, this angle is 360. So that means those two has to be the same. So and then dividing by 2, you can simplify this result by dividing by 2. So that means you can write this result as radian pi in radian has to be equals to 180. If you divide by 2, you get 180. So it is 180 degrees. So this is a kind of conversion factor. So we're going to use this to convert between radian and degrees. So let's see how it works. And also this result, you can write this one as, because you can see this is just one turn. So that means sometimes we also call one revolution is equal to, in degrees, radian is 2 pi radian, or 360 degrees. So this is like another formula that we're going to use later. So one revolution or one turn is equals to 2 pi radian or 360 degrees. So let's focus more on the radian degree conversion. So we have pi radian equal 180 degrees. Now dividing by pi, you can say, because there are pi is a number, so pi means radian. So that means you can say then 1 radian. So then the 1 radian as a divided by pi, you can say 1 radian is equals to 180 over pi many degrees. And similarly, the other way, you can divide by 180, you can say 1 degree is equals to pi over 180 um, pi over 180 radians. So this is we use to convert between the two. So this is when you want to convert to degrees. This one we can use to convert to radians. So let's look at some examples. So we do this problem. So convert to radian. So we have several degree values. So let's look at one by one. So the answer. So A. So we start with the 60 degrees. We can write this one as 60 times 1 degree. But we know that 1 degree is equals to pi over 180 pi over 180. So there's no degree here. Pi over 180 radian. Now we can see we can simplify this one. There are 60. There are 3 of them. So that means the answer is pi over 3 radians. So let's look at the next one. B. So we have 120. You can just multiply the previous answer by 2, but also let's do like as a regular problem. So it's 120 times 1 degree, and actually just don't put the degrees, only in the second one. And then it's 120 it's automatically we write this one times 1 degree equal as before pi over 180. Now we're gonna find the common factors and cancel, and you can see that there are 2 60s, there are 3 60s. So that means it is 2 pi over 3 radians. Part C, negative 135. Negative is just a number, so it's negative 135 times 1 degree, and then negative 135 times pi over 180. So how to simplify this one? If you think of factors, and you can see that there are 3 45s here. There are 4 45s there. And if you cannot do that, first divide by 5 and then divide by, I mean, you can do it like that. And then divide by 3 like that. Okay, so the answer going to be now is negative 3 pi over 4 radian. So part D, 90 degrees, and again is 90 times 1 degree, which is pi over 180, and then you can see that this cancel, there are 1 and there are 2, so that means it's pi over 2 radian. 90 degrees means. So that's how you do those conversions, and it's not that difficult. So let's look at the other way. Convert to degrees. Convert to degrees. So let's look at the first one. So pi over 6. So it's pi over 6 many radians. So we know that the 1 radian equal 180 over pi. So we write it so that the pi and pi get cancelled. So you can see they're going to cancel out. And then 6 going to cancel with 18. So it's 3. So that means you get 30. So this is 30 degrees. Part B, pi over 4. So again, pi over 4, 1 radian equal 180 over pi many degrees. And again, simplifies. So you can see there are 4 of them. So it is 45 degrees. And part C, negative 3 pi over 2. So this is negative 3 pi over 2 times 180 over pi. So as before, we can cancel out that, and 2 cancel with 18, which is 9, so again 90. So 90 times 3 with the negative sign negative, 90 times 3 means 270, so 270. And part D, it is 7 pi over 3. So it is 7 pi over 3. 1 radian is equals to 180 over pi. So again, these get cancelled. There are 6 of them. So 7 times 6 means 42. So that means you're going to get 42 and a 0. So that's how many degrees 7 pi over 3 equals to. And then E is equal to 3. So if you have 3, we just do the same thing. So 3 times 180 over pi. Now what we have to do is we will substitute the value for pi. So if you plug in the value, so you're going to get 540 divided by the approximation 3.1415. So it's approximately equal. This is also an approximation. So it's approximately equal to, if you simplify, you can see that 171.89. So this is less than 180 degrees. And then let's do one last problem. Let's see what is 1 radian equals to. So I'm going to call this F. So 1 radian. So 1 radian equal 1 times, again, 180 over pi. So we're going to approximate this one. So it's 180 approximate to 3.1415. And if it's calculated, and you can see that this is equal to 57.29 something. So it's approximately, if you round it to, it's going to get 30. So 57.30 degrees is 1 radian equals to. Okay, and also sometimes students like to use another formula, like another formula. Let's call it another formula. You can also write a conversion formula like this. Let's say degree value divided by 180 equal the radian value divided by pi. So this also can be used as a formula. That means if you know one, you can find the other one. So let's use this formula to do, like, for example, so let's say let's convert 135. Let's say we have 135. So we'll convert this into radian. So what we can do, we can divide this one by 180. Then this equals to the radian value over pi. So if you simplify, you can see the radian value equal 135 divided by 180 times pi. And if you can simplify, and you can see there are 3 of 45, there are 4 of 45. That means it is 3 pi over 4. So that's another way to find it. So you plug in the one that you know and solve for the unknown. So that's what we can do. So that's how you use the formula. So as exercise, see whether you can find this using the new formula. So let's say negative 225 and let's say 720. So try to convert this into radians using this new formula. Okay, so that's about that. So let's talk about some of the common values that you need to know. This will be very useful when you try to solve problems. So some of the common values. So let's write them in a table. So we have from 0 to 180. These are very common values. So let's write the answer. So with 0 degree equals 0 radian. We just say 0. We don't say anything else. We don't put any units. So 30, you can use the conversion, and you can see that this is pi over 6. And 45, this is pi over 4. 60, which is pi over 3. 90, which is pi over 2. And this is 2 pi over 3. This is 3 pi over 4. This is 5 pi over 6. So that's a nice pattern, just one less. So you can see there is 1, 2, 3, 4, 5, and then 1, 2, 3, 5, just one more. And then 180, which is pi. So that's the first set. So, and let's talk about the other set. And these are the other values is 180, 210, 225, 240, 270, 300, 315, 330, and 360. So let's write the value. So this is pi. And then you can see 210, this is like 7 times 30. So you can write this one as 7 pi over 6. And then this is 5 pi over 4. And then this is 4 pi over 3. And this is 3 pi over 2. And then 5 pi over 3. And then we have 7 pi over 4. And then 11 pi over 6. And then this is 2 pi. And then you can see that these are the quadrantal angles which are on the either x-axis or y-axis. Good. So those are some common values, and you can see that this is going to repeat many times. So this is common values. So there are like two major things to remember about the radians. So let's say things to remember. So the first one is the quadrants. So let's look at the quadrants and how those angle looks like. So this is the quadrant 1, quadrant 2, and quadrant 3, and quadrant 4. So this is the angle theta equal 0, and theta equal pi over 2, theta equal pi, theta equal 3 pi over 2, and if you complete the full cycle, theta equal 2 pi, so they're going to come back to the same place. So those are the 4 quadrants, and also these values will be very useful. So for example, pi over 6 equals 30 degrees, pi over 4 equal 45 degrees, and then pi over 3 equals 60 degrees, and pi over 2 equal 90 degrees. So just knowing this one can help you a lot in calculations. So also we can see that it is very easy to work with radians compared to degrees. And also I wanna like we gonna remember this one also. So this is the all those common angles. So this is so exactly in between. This is 45 or this is pi over 4, and then if you cut the angle into 3 parts, you're gonna get 30 and 60. That's what happened when you cut the 90 degree into 3 parts. So this is pi over 6, and this is pi over 3. So those things will be useful when we do problems. So this is 90 degrees. So you have to get familiarized with these things. And you can see that it's very easy to work with radians compared to degrees. So I'm going to say easy to work with radians. So let's look at how to draw certain angles in radians. So draw the angles. So let's start with a few. So let's say the first one is 2 pi over 3. So how to draw this angle? So we can make a simple observation. We can write this one as we can say 2/3 pi. We know that the pi means a straight angle. So that means you can get 2/3 of that. So we can look at this one as 2/3 of a straight angle. So that is the easiest way to look at this one rather than evaluating this angle. So 2/3 of a straight angle. So straight angle means pi. The straight angle means pi. So that means you only get 2/3 of that. So we're going to cut into 3 parts and pick 2 of them. So that means so it's going to look like this. So we're going to cut this angle into 3 parts, straight angle into 3 parts. So it's going to be 1, 2, like that. So we're going to pick 2 of them. So that means so the angle going to look like this. So that's the idea. So that is the angle. So that's roughly 2 pi over 3 because it's 2/3 of the straight angle. So that's the easiest way to look at this one. So this is starting good. And this angle is in the second quadrant. The other way is we can actually convert this into degrees. So it is 2/3. Pi means 180. That's another way to do that. Just replace pi. And then you can see you can simplify this one. This is 3, this is 6, that means you can 60. So 6 times 2 means 120 degrees. So that's, and then you draw 120. So that's like other way to look at this problem. Good. So let's look at another one. So let's say negative 2 pi over 3. So when you have a negative sign, only thing change here is it's gonna change the direction. So that means it's very similar to the previous one. So what happened? It's gonna go backward. So it's gonna be like that. So that's the negative 2 pi over 3. So the size has to be the same, but it's just gonna go backward. So that is the negative 2 pi over 3. Very easy to draw it like that. So we don't need any conversion here. And you can see the angle is in the third quadrant now. Okay, so let's do another one. Part C. How about 4 pi over 3? We have 4 pi over 3. We're going to look at this like this. We can write 4 as 3 plus 1 over 3 times pi. Then we can write this one as 3 over 3 plus 1 over 3 pi. So 3 over 3 means 1. So 1 plus 1/3 pi. So again, pi means a straight line, a straight angle. So how you gonna think of this is you go one straight angle and 1/3 of that. So that's the easiest way to think about this one. But once you get used to it, it will be very clear. And also we make another argument later. We can look at the multiples of 3. So this is a kind of idea. But let's look at the first one. And once you do a couple of examples, it will be very clear for you. So let's say, so we have this. So we're gonna go. So what it says, go one cycle, like one straight angle. So I'm gonna do one straight angle, and then 1/3 of a straight angle. So just 1/3. So it's gonna be like, so we go 1 and then 1/3. So it's be like this. So that's the idea. So that's the angle. So you go 1 and then 1/3. 1 means straight angle. So, yeah. So this is the 1 we are talking about, and this is the 1/3 we are talking about. So 1/3 of a straight angle. Yeah. So this is the angle. So it is 4 pi over 3. But when you get used to it, it will be very, very clear. If it is the first time, or maybe you have never heard of this method, it will be difficult, but later it will be easy. The other method is you can convert this into degrees, but I don't recommend that because it's like wasting time. But once you get used to it, it will be very clear and easy. So this angle is in the third quadrant. So let's do, and the other method is another one is you can count. So what we can do, we can think of multiples of the denominator. So the multiple denominator is 3. So we can think of multiples of the denominator. So that's the other way. So think of multiples multiples of the denominator. So it's 3. So what we can do, we can count multiples. So we can start with 0. That's the another method. So we can put like 0, and then the next multiple of 3 is 3. And then what you're going to do, you're going to compare with the numerator. Numerator is a 4. So if it's 4 means you have to go a little bit more, like 1/3 of another 1/3. So that's the other way. You just look at the multiples of the denominator and then see whether it's a more or less. If it's less, you go backward. If it's more, you go forward. So you have to go uh, another 1/3. So that's the other way. Just look at the multiples. And I'm going to do that in another few examples, and it will be clear what I'm talking about here. So let's look at this one. So let's say t. Let's say we have 7 pi over 4. So you can see the denominator is 4. So I'm going to think of multiples of 4. So let's see how we can use this idea here. So we're going to start multiples of 4. So it is, you have 0, and then 4, and then 8. So you can see 7 is 1 less than that. So that means, what is 1 here means? 1 means pi over 4. So it's a pi over 4 less than. So that means it has to be here. So that's the idea. So you look at again 0, 4, 8. Since this is 7, so it's pi over 4 less than that 8. So that means your angle is this. That's the angle. Because you can see, and there is that pi over 4, the missing pi over 4. So that part is missing because it's not 8, it is 7. So one part of that is missing. So that's the angle 7 pi over 4. So that's the easiest way to do it. So it's very easy to draw angles like that. And then you can see this angle is in the fourth quadrant. So the fourth quadrant. We use Roman letters for that. Okay. So and then E. So let's do this one. Let's say 7 pi over 6. So again, think of the multiplication argument. So we can look at the multiples of 6. So we can start with 0, 6, yeah, 7. That means it's on the third quadrant. So it's a pi over 6. Pi over 6 is 30. So like just a little. So like that. So that's the angle we are talking about. So this is 7 pi over 6. Yeah, so the multiplication argument is much easier than you can directly say where it is. So try to get used to it. Just try to draw these angles again by yourself until you are really comfortable with this argument. So let's do 3 more of them. This is F. So negative pi over 2. So we can see that this is one of the quadrantal angles. So this is negative, so we're going to go backward, and so the angle is just the angle, so it is negative pi over 2, and you go backward. And G, let's say negative 5 pi over 3. So again, we can look at the multiple. It's going to go backward, that's one thing, and also we need to look at the multiples. So if you look at the multiples, and you can see, so you can start with 0, and then 3, and then 6. So you go backward, but it's 5. That means this is 1 less, so it's going to be to the first quadrant. So this angle is in the first quadrant. So it's going to start here with negative, so it's going to go backward, and then pi over 3. So it's going to go like that and stops here. That's the angle we are talking about. So this is negative 5 pi over 3. So you look at the multiples. Look at the multiples, and you see that it's 5, so you have to stay here. it did not go to 6. So that's the reason why it's in the first quadrant. Okay, so let's do one last problem. So let's try to do h. So let's say this is 25 pi over 6. So the counting argument would be the easiest for this one. You look at the multiples of 6. So we're going to get, as before, we're going to count the multiples. So we're going to start with 0, and then 6, and then 12, and then 18, and then 24. So this is 25, that means just pi over 6 more than that, so that means it's going to go there. So now if you draw the circles, so you see it is 0, then so 6, 12, 18, 24, 25. So that's where the angle is. Yeah. So if you get used to it, this will be much easier. So it is 25 pi over 6. And there, another way to look at it, you can break this into multiples of 6. So that means you can write this one as 24 plus 1 over 6 pi. Why we do that, then you can see when you divide 24 by 6, it is 4. That means you can write this one as 4 pi, that means 2 circles, plus pi over 6. That's the other way to look at this one. So this is how you draw certain angles in radians, and you can see that it's much easier compared to degrees. And you don't want to convert, you can directly graph the radians if you remember those small facts. Okay, let's look at some coterminal angles using radians now. So let's look at this problem. Find a positive and a negative angle that are coterminal to 5 pi over 3. So that means there should be the same terminal side for those two angles. So in theory, what we say that adding or subtracting multiples of 2 pi gives you coterminal angles. So that's the theory. So adding or subtracting multiples of 2 pi. 2 pi means full circle. Multiples of 2 pi give coterminal angles. So let's look at a positive one. So for the positive one, so what we can do is, so it is 5 pi over 3 plus 2 pi. And then you can simplify this one. So it is 5 pi over 3 plus, take the common denominator, so it's going to be 6 pi. So 6 over 3 pi. So that means it's going to be 11 over 3 pi. So that angle is coterminal to 5 pi over 3. Let's look at a negative angle. So the negative angle is subtract. So 5 pi over 3 minus 2 pi. So if you do not get a negative angle, subtract 2 pi again, so until you get a negative angle. But when you do that, you can see this 5 pi over 3 minus again, we multiply by 3 top number, so 6 pi over 3, and you can see this negative pi over 3. That's a negative angle. So this is a positive angle, and this is a negative angle. They are all coterminal because we go full cycle. When you add those full cycles, they are coterminal. So let's graph this situation, and if you graph it, this is what's gonna happen. So it is, we can look at the multiples of 3, so that is going to be 0, 3, 6. So the angle is in the fourth quadrant. So so that's the angle, the original angle. Now how to get the other angle? So to get the other angle, we go one more cycle. So if you go one more cycle, you get the positive angle. So if you go one more cycle, that's the positive angle. So which is 11,503, and then go backward. You can see if you go backward, you subtract. So that means you can start with this angle and you subtract one cycle, and then you end up with this. So this is negative pi over 3, and you can see that they are all coterminal because they have the exact same terminal side. So the terminal side is the same. That's the terminal side. You can see that they are all coterminal. Good. So let's do one final problem. Let's try to find a general formula for the coterminal angles. So let's do this as another problem. So the problem says find a formula, or give a formula for all the coterminal angles of 5 pi over 4. So what we want to do is we're gonna either add multiples of 2 pi or subtract multiples of 2 pi. To do the easy way to do that is in math. What we do is that theta, that's the coterminal angles, which is 5 pi over 4. We can write like that. We can say 2 pi times k, where k is an integer. Where k is an integer. So that is the easiest way to get all the coterminal angles. So adding different values of k, all the values of all the coterminal values. For example, 5 pi over 4, let's say 2 pi. That is one angle. Let's say 5 pi over 4 plus 6 pi. This is another angle. Or let's say 5 pi over 4 plus let's say 107. Actually, it'll be like it's actually even numbers. Yeah, 107 doesn't work, but you can say 1007 pi. So those are all coterminal angles. Those are all positive. You get the negatives like 5 pi over 4 minus 2 pi, and then you can say 5 pi over 4 minus 2022 pi, so like that. So 5 pi over 4 minus 10 pi, things like that. Those are all coterminal. There are infinite numbers like that. So those are all coterminal angles. Okay, so that's about the radian mission. So as another measure for angles, let's just talk about the revolution argument, just to complete the discussion. So revolution is also another way to measure angles. So one revolution, so we say one revolution, that means it's one complete cycle. So we can say that this is one revolution, so we say REV. And then it's very clear that one revolution is equals to complete cycle. That means it is either 2 pi radian or 360 degrees. So we can do some problems. So let's say the first one. Let's say find the following radian. So find the following in radian. Find the following in radian. So we can convert radian. So let's look at the 3 examples. Let's say 2 revolutions. How much 2 revolutions? So we know that the 2 times 1 revolution. So 1 revolution is 2 pi radian. So that means 4 pi radian. So 2 revolution means 4 pi radian. B, let's say 1/2 revolution. So again it's a 1/2. 1 revolution means 2 pi. That means pi radian. So 1/2 revolution means pi radian. It's very clear because if you draw it, so half a revolution means just that. But we know that this is the pi angle. In angle is pi, or in revolutions is half a revolution. So half revolution. We did not complete the full cycle. Okay. Part C. let's say 5/4 revolution. So it's again 5/4, and 1 revolution means 5, so we can multiply by that. We can replace the revolution by 2 pi. That's how we do it. It is in radian. So and then you can simplify this one, so you're gonna get 5/2 pi radian. So that's how you convert revolutions to a radian. So now let's convert revolutions to degrees. So the next example, find the following in degrees. Find the following in degrees. So we're going to convert degrees. So let's look at the first one, 3 revolutions. So now we can replace the revolution by degrees. We know that 1 revolution is 360 degrees, so it's 3 times 360. So we're going to multiply, so you're going to get 10 degrees, 3 revolutions. B, 3 half revolution. So again, 3 half times 360. If you simplify, you're going to get 540 degrees. Part C, let's say 5 revolution. So 5 times 1 revolution means 360 degrees. So when you multiply, you get 1800 degrees. That's how you convert revolutions to degrees. So let's look at one practical problem. So these are like very common. Sometimes we measure speed in revolutions per minute. So that means how many revolutions it's gonna make per minute. So this is like how you kind of measure the speed of a automobile engine, of a fan, or even hard disk. So things like that. So let's look at one problem like that. So the question is, if a hard disk makes 5400 RPM. We use RPM for that. What RPM means? Revolutions per minute. That means how many turns it makes per minute. Find the angle in degrees it makes in 1 second. So our question is, in 1 second, what kind of turn it's gonna make? What's the angle it's gonna make? So so this is a very interesting question. So how we can answer this question is, and you can see that for 1 minute it's gonna make 5400 turns. So the answer, so we can say a number of revolutions in 1 minute in 1 minute is equal to 540. That's for 1 minute. And then you can see that then how many in 1 second. So I mean you have divided by 600. So then the number of turns, the number of revolutions, the number of turns, then the number of turns it makes in 1 second is, because we know that 1 minute means 60 seconds, you have divided by 60 parts, is 5400 divided by 60. So this is, you can see that 9. So there are 9 revolutions it's going to make, 9. But we know that 1 revolution means you can make 360 degrees. So that means, and then you can see, so you can write next, since, you can say since 1 revolution is equal to 360 degrees, you can say the angle it makes in 1 second is, you can see that it is 90 revolutions, 90 revolutions, but we know that per second, 90 revolutions per second, that's what happened. But we know that in one revolution, it's gonna make 360 degrees. That's how you do the calculation, and you can see it cancel out. So you simply get, you have to multiply the two numbers, so you're gonna get 23400 degrees per second. Per second. So it's gonna make this much degrees in a second, and you can see it's really fast. It's going in really fast. So this is like a standard hard disk drive. They go like either 5400 or 7200. Those are like kind of common values. It's going to be in the range 5400 to 7200 RPM. But this number can increase over time, but right now we can see these numbers. So you can see how you can use the mathematics to understand certain problems. Okay, so that's about the basics of measuring angles. And next we talk about some applications of how to use these things. Okay.